Welcome to the video on dissolution medium pH. The dissolution media pH has a great role in the drug substance solubility, drug substance stability. Also, the dissolution medium pH affects the solubility of particular formulation excipient and it provides the biorelevance in vivo. Dissolution medium pH is to be critically studied, evaluated and finalized to perform the dissolution test. There are various formulations types like immediate release, modified release or delayed release. And there are various dissolution medium with pH like 1.2, 4.5, 6.8, 7.5, 7.2 and many more. Each drug, each formulation is having some specific nature, specific solubility and the specific biorelevant requirement. So, based on those properties of the drug substance, formulation, excipients, the desired release, the medium pH is finalized. For IR formulations, the purpose is to cover the GI pH range for quick release. Also understand the BCS class of the API. For modified release, simulate entire GI transit for the sustained release. And for delayed release type or gastro-resistant formulations, which may be tablet or pellets, also called as delayed release, enteric release. This ensure the drug release bypass the release in the stomach. So first 1.2 pH is there, followed by dissolution in the pH 6.8 or 7.5 depending on to the formulation. So we should understand the pH effect onto the drug release. Now how the pH is to be finalized? First we need to consider the physiological relevance. We should evaluate the ionization potential, we should study it. We should understand the pK of the drug versus pH relationship. Also we should check the BCS classification, whether the drug is soluble, insoluble. We should analyze dose and the solubility. We should check the sink condition and then we can select the specific dissolution media and its pH. So we need to justify the media and the media pH scientifically based on the formulation, based on the API properties. Evaluating the ionization potential, pK versus pH relationship. Understand the ionization behavior of the drug molecule. It impacts the solubility and thus solubility has impact onto dissolution. Drug is soluble or it dissolves best in its ionized form because in this form it interacts more readily with the aqueous media. Let's see the general rules. Weak acids show improved solubility when pH is above pK. Weak bases dissolve better when pH is less than pK. Therefore, compare the drug pK value to potential dissolution pH levels and select the medium where the drug is more likely to stay ionized and soluble. Because if it is not soluble, the dissolution results will not be robust and these will vary from batch to batch and from day to day. Account for the BCS class. So 4 BCS classes are there. BCS 1, 2, 3 and 4. BCS class 1 and 3 are highly soluble. BCS class 2 and 4, these are the low soluble. Also, we need to check the pH dependency onto the solubility, or in other words you can say the pH dependent solubility. So as per the BCS, we need to check whether the dissolution becomes rate limiting for the absorption, permeability or not. Optimizing pH to improve solubility is essential for accurate in vitro in vivo correlation. We should also get good IVIVC so that we can formulate the robust, stable, and bioequivalent formulations. This is the second point. Now, another point is analyze dose versus solubility, that is sink condition. I have made many videos on the dissolution. I request you to go through those videos. Sink condition is desirable, but it is not mandatory. We need to show the discriminatory nature of the formulation, and first, we should always try to get the sink condition. Sink condition is considering the dose, highest strength of the formulation, and if we achieve the sink condition, then we can justify that the dissolution is reproducible and dissolution variation is not because of the lower solubility. We can say the sink condition is achieved when the media and media volume is capable to dissolve the 3 times of the dose of the drug compared to the highest strength. If sink condition is not being achieved for low soluble drugs, we can use the surfactants. Then another point, scientifically justify the selected dissolution media. We should support the medium pH through the sound scientific rationale. We should show the experimental evidence for the solubility studies, dissolution profiles, dissolution in the different medias, multimedia dissolution. We should check the dissolution of RLD or reference formulation. We should provide the scientific literature and pharmacopoeial references if monograph is available. We should provide BCS base rationale. We should check and we should provide the rationale considering the matching GI conditions, PK of the drug, and BCS strategy. Ensure the rationale is well documented and logically consistent with the product specific characteristics and intended site of action. So if the formulation is like enteric coated, we should show its dissolution in the basic pH and it should not release in the acidic pH. Similarly, for the drug products which are immediate release containing highly soluble drug substances, we should check the dissolution in acidic pH considering the 0.1 normal HCl. If the IR formulation is containing the low soluble APIs, we can use the surfactants and we can select the pH considering the BCS, solubility, sink condition, and the site of absorption. This is the short information regarding the selection and justification for the dissolution medium pH. Thank you for watching the video.